welcome everybody to this episode of Alumni in the Industry. My name is Lori. I'm the project manager here at the Iceland School of Energy. Today with us, we have Máté Osvald from the graduating class of 2016. On Alumni in the Industry, we basically bring back alumni who've been out and have graduated and are doing cool stuff in energy, and bring them back to basically talk to our community, talk to other alumni, and also current students as well, and potentially prospective students. So Máté, you're going to introduce yourself, right?
Yes.
All right. Well, then I'll just leave the floor to you and just say thank you for joining us on this call. And yeah, feel free to start whenever you're ready.
Thank you very much for having me. Well, let me first say I'm very glad that this series of event is existing. It helps us to connect, keep in touch with former colleagues, friends, classmates, and it just helps information to flow between countries. I'm super curious what happens in Iceland with this volcano. If something interesting is happening in my country, probably I am sharing that as well. So I'm fully in support of these events. Thank you for inviting me. Very briefly, I'm going to talk about my introduction. So how I got to Iceland, very briefly what I did there. And I'm going to give you a short overview of my activities since then. It's rather informal, friendly talk, which means I'm only going into technical details if you are interested. I can, of course, go into technical details, but that's more for the Q&A. It's going to be half an hour presentation from me or so. During the conferences, I was always the one who saved the time, because when it came to my time to present, we were always in a few minutes late. Well, I'm used to it. I'm going to be brief. So my name is Máté Osvald. I'm Hungarian. Right now, I am based in Hungary, and I'm a project manager at the Hungarian Power Company. You can see my emails there if you have any inquiries. I live at the southern part of the country. This is Europe. We call it Central Europe. Some call it Eastern Europe, but it's better for us to call it Central Europe. I'm at the southern border of this country, next to the Serbian border. I am a biochemical engineering by training. I went to university here, to this town. Then I went to Iceland to be a sustainable energy engineer. And then I came back to continue and start doctoral studies. I always was interdisciplinary. I always worked with on the borders of different subjects, geology, biology, or geology and chemistry. It's not a conventional mechanical or electrical engineering what I am. Yeah, it's just a few pictures of the city. This country basically has the Danube going through here. You cannot see on this picture, but there is another large river called Tisa. It goes through this city, so it has this river. It's pretty nice. It's about the size of Reykjavik in population, together with students. Let me start what I did before Iceland. At one point in my career, I decided that I want to do something with environmental protection and renewable energies. Then there was a set of presentations where representative of each renewable energy, solar, geothermal, wind, gave a talk. And then I approached one of the presenters, who later became my professor and the supervisor during my studies. When I was younger, here in Hungary, I preferred some kind of field work or laboratory work. I went to study geothermal energy, but they wanted to utilize that I know some stuff about biology. Therefore, they suggested that I study biological aspects of the geothermal energy. There is a nearby town who utilizes geothermal energy since a long time, since a very long time, and they have had, probably still have some problems with operation. At that time, the reinjection was problematic. So it's a cascade system. You produce hot water from the production wells, circulate it in the city, use it for whatever uses you want, thermal baths, heating, etc. And then you reinject it to the subsurface. Before reinjection, you have these kind of things. These are filters. There are 5 + 5 filters here. At one time, only one part is working. My studies included that taking this apart, pulling this tube outside, hanging it outside. It's more than 1 meter long. It's a large filter. Originally, when we replace it, it's completely white. It's plastic white filter. Due to reinjection, it became fully black. My task was to determine the origin of this plugging. There were instances when a few hours, 3, 4, 6 hours passed after replacing the filters, and it clogged again. So it was super interesting. Why is it clogging so much? Technicians have to go on field, disassemble the whole thing again, and then replace the filters. It costs a lot of money. I took samples from this filter, took it to the laboratory, and basically I found out it has biological origins. We determined exactly the species of bacteria, extracted them, so we pulled their DNA out, and with a super modern technology, we did a so-called metagenomic sequencing, which helped us to determine what is it. This, we can say, was the beginning of my scientific career. I attended to some youth conferences, some smaller talks, smaller papers, and so on. I think we already in 2014, we put together, of course, not alone, but together a paper to the World Geothermal Congress, which at the time was in Melbourne. Of course, I didn't go there, but my name was there. After it, pretty much on my birthday, which is in March, I decided that okay, I want to go to Iceland. They accepted me to the school. We did some administration, and then from July, I think, or maybe August. I think it's more July, because summer school before the official program starts a bit earlier, and I started my studies in Iceland. I'm going to be brief here because it's not the point of this presentation to introduce this. So this school went by. It was a very high-level education with a lot of internationals. First impressions is people speaking English everywhere. Oh, how am I going to understand this? And then we go to the pubs, and they are like Canadians and Americans talking to each other super quickly. Like, wow, it's gonna be rough. But this was the time when probably my English improved to a better standard where it is now. I think it peaked during Iceland. So where was I? Yeah, I was doing my studies, going to classes, etc. And then I came to a point where I had to choose a place for internship, and I was lucky because it helped me to pay the tuition, and also I could do my research and write my master's thesis in the Research and Development Center of the Blue Lagoon. This was, well, me every week. after work because Blue Lagoon was a super nice employer. They organized my shuttle from Reykjavik, the capital city, to the Blue Lagoon, which is 45 minutes far. I think the volcanic eruption is happening close to the Blue Lagoon, so it's pretty close to the capital city. And the buses went in every hour to and from the Blue Lagoon. And if I felt after work I could take a bus, I had the opportunity. This is not the only thing I did at the R&D center of the Blue Lagoon. My main task was to cultivate algae. Even though this is not a scientific talk, let me say these are not algae, these are bacteria. But products from the Blue Lagoon go for, how to say, human use, cosmetics, algae mask, and so on. And people don't like to hear the word bacteria when they put something on their face or if they bathe in something. So they are cyanobacteria, so-called blue algae. They are cultivating it in a super renewable way from effluents of a geothermal power plant. On the gases of the geothermal power plant, they have photobioreactors, like basically pipes, which go parallel to each other. They illuminate it with some modern lights, and their algae is growing there. My task was to convert this already renewable algae to something more renewable, or add some cream on top of the cake. So on high temperature and high pressure, I squeezed them and converted their biomass into oil. Then I did some laboratory stuff, let's say, heated rotating shakers, vacuum, and so on. And then I could squeeze some oil, not just squeeze some oil out of them, because they have oil, yes, but convert something in them which was not oil before. I'm not sure how this turned out. I think I'm still owing them a scientific article. Now I can say it's not probable that I'm going to publish it. But if we meet from time to time at a scientific conference, we say hi to each other, we agree that, yeah, we could publish something together. You know, it's something we have in common. Yeah, I'm going to come back to this Blue Lagoon at one point. Then I successfully wrote and defended my thesis, then came back to Hungary. I came back to Hungary shortly. For a few months. I looked for a job, and then decided my best opportunity at the time was to start PhD studies, doctoral studies, which included a small amount of time in the small amount of time of teaching others, teaching students, having some practices, taking them to see renewable energy opportunities in the city of Szeged. We went to rooftops of municipal and university buildings to check solar panels. At the time, it was pretty new, and people couldn't just go there, and they didn't have access. But we could organize it, and you know, it was cool. You went outside the classroom. I could utilize many of my previous studies. We had special topics in engineering, and I was teaching geologists and earth scientists. I could implement some of my knowledge, how to measure the amount of the power plant, which can be designed to a special area, special geothermal area. As I said, this was just a small portion of my activities. My main goal was, of course, my own research. This I'm just thinking maybe it's better if I go here, explain it here, and then go back. So there was the idea of a huge European project that if we have a geothermal reservoir and we can find some metals in it, metal enrichments, we can generate fractures by pumping cold water in it. Through fracture systems, it migrates to our production well. There we produce electricity and heat with it. We can also extract the metals. This is called combined heat, power, and metal extraction. 2030 is our vision that by then it might happen. This European project formulated the idea, and I was working on this project parallel to my studies. First, I started as a scientist, went to the laboratory, designing, and there I go back, designing this machine, validating, operating this machine, then having the results, comparing, interpreting, and reporting them. So from A to Z. This machine is a high pressure, high temperature reactor, just like I did in Iceland. You remember my algae were put under high pressure and high temperature. This has the pressure, this has the physical circumstances of a geothermal reservoir. Maximum 300 degrees Celsius and 250 bars, which correspond to a depth of 2.5 kilometers. I put specific metallic ground rock in it. So we crushed them and I filled this reactor with it. And then I flew many different fluids through it. And then I see what came out. Just as a living example, it's almost like making coffee. Only you don't put coffee in this reactor, you put ground rock. Pressure and temperature is a bit higher. And yeah, I also put water through it, but then I put acetic acid, different kind of pH fluids, and surprisingly also Coca-Cola or cola, because it's full phosphoric acid. It potentially can dissolve useful materials. This, what I said, is the idea of the so-called CHPM project. What was special about my doctoral research, that my focus was on special element tungsten, wolframite. This is a critical and high-risk metal in the European Union, determined officially, because most of it is imported from China, and if something happens to the import, then we are not in a good geopolitical position. So we are looking for solutions how to, get this thing. Two main sources were found. One is the mineral ferberite, and the other one is scheelite. This is a schematic of the inside of my reactor. I put both scheelite and ferberite and inert material such as quartz just to fill it up, and then completely investigated it. Had water, acetic acid, a mixture of almost like aqua regia, but in a very dilute way, because we have to be environmental friendly, because we are putting things below surface. We had a huge responsibility in determining what is good for the environment. Okay, we can dissolve anything if you choose the right solution, but you are never going to officially put it underground. So we had to take into account that it has to be socially acceptable. One of the best solutions was vinegar, because when you put something below surface, you're not only dissolving useful materials, you are also dissolving which is not useful. When Laurie wrote my introduction, he wrote that I have completed my PhD studies. Well, it's not true. I have my absolutorium. I completed all my requirements, like lectures, language exams, by the end of last August. Since then, I wrote my dissertation, submitted it by December, and a few weeks ago I got a professional opinion on it. All of them were supportive, and therefore I have to defend it. I have a green light. It's going to be in early May. Then probably or hopefully my studies will be finished. So
I was going to say, I was just off of your LinkedIn profile.
Okay, I'm going to modify it. Or yeah. So parallel to my doctoral studies, it was a huge motivation to work in a European consortium, because I'm doing something innovative, doing something good, something useful. I'm in the middle of this picture. You can see it's young people, older people, females, males. It was I think 12 countries, or no, 12 partners from 10 different countries. It was a mixture of very good people. It was super nice experience. Of course, freshly graduated, working in such project. This is a group picture made in Iceland, because in every half year we had consortium meetings at each partners. Okay, there were partners from Hungary. Those are not too interesting for me, but there were partners from Canary Islands, Iceland, and other European countries, which were super nice. Here on the photo, I'm only showing this because that's me, but I'm only showing this because in the middle of the photo, you can see the lady in the cookie hat. She is Vigdis Hardardottir from ESOR. She was one of my teachers during my master's. And two other guys from ESOR, who is owning ISC together, I think, so that they have a large portion in the education. Back there in the glasses, he's Hjalti. He was the surface geologist at ESOR. He also was a teacher of mine. And other people are on the picture from ESOR, but they were not teaching me. So I'm freshly out of the school, and I'm already having some familiar faces in an international consortium. It was super nice working together with them. So let's say I'm going to finish my doctoral studies. This project ended in last June or July. It lasted 3.5 years. Last August, my studies were finished, so I was looking for a job. I was prepared. I knew how long this program is going to last. So I started to look for a job, and luckily I could get one. Now I am a project manager at the Hungarian Electrical Works. I got some PR slides. I think my company sent me more than 40 slides about the company. I'm showing you 2 or 3. This is a large company owned by the country. Is the 4th largest in this country, 13th largest in Central Europe. It has more than 17,000 employees. This company, this group of companies deals with gas storage, electricity production, and distribution as well. I am within this group. I am at the so-called DSO, distribution system operator. This company distributes the electricity to the households from the grid. My main tasks are basically to help the grid be alive in 5 years. This means this grid is old. It's 30, 40 years old, and it's not really renewed. Okay, it's extended, new parts are built because there are more people trying to connect, but it's not really modern. And this is only prepared to distribute electricity from the power plant to the user. And fast forward since that time, solar panels, wind energy, and many other remote sources of electricity appeared. Therefore, people from all over the city, all over the country, trying to connect to this grid and not take energy, but produce electricity to the grid. Well, this is of course good. We have to go to this way, but this is a problem and a challenge in terms of the grid. Because of course, everybody wants to produce electricity in the middle of August at noon. Who needs that electricity? Do you need it? And we might have a deal. This is exactly my role here. We are working on the so-called flexibility of the grid. This involves flexible demand and flexible supply as well. In the first part, we have a roadmap of many years. We start with electricity producers, so not by domestic. We are not going to control your sole solar panel, but with solar panel farms and power plants. We might just well, turn them down or switch them off when the grid is not capable of accepting their electricity. Of course, we are going to have a contract with them. If they enter into this program, they get some kind of remuneration. This will be good for them, because so far that's the best tool we have. In the future, we are working on tariffs as well, but that is not going to influence as much. Electricity is, compared to European standards, is cheap in Hungary. We might, if we increase the price of electricity at a given set of time, for example, when there is a peak of consumptions, everybody goes home from work, switch on the light, switch on the oven, start vacuum cleaning. We might say that, please don't connect your electric car to the grid right now. It will be cheaper for you to do it during the night. So this is the price which we can influence, but this is not at a so large level where we are now. There is, I think, our transmission system at this region is around 700 megawatt. It's the traffic, and the request for solar panels is 2 gigawatts, 2,000 megawatts. So it's much more than we can accept, much more than we can distribute and than we can use. What I mentioned in the past few minutes was controlling, influencing, and trying to convince the consumers. Other side, when we can achieve flexibility, is incentives for the producers. No, for the energy usage. For example, if we have a lot of energy, we would not turn down a solar panel or a solar power plant, but start something very energy consuming and utilize the energy in a so-called power to, it's an example, for example, a power to gas situation. There is now a project. I am not involved in this, but it can be a very good idea to utilizing DSO flexibility. This project converts water to hydrogen. This needs a lot of electricity. They can do it whenever. it doesn't matter to them when they do it. And then they add this hydrogen to the gas distribution system. So in the future, it might happen that few percent of your natural gas in your household contains hydrogen. Because our company group also deals with electricity, but also with the gas. So it's good to have many different companies in the same family, we can say. They can help each other. They split the water into hydrogen and oxygen. They pressurize the hydrogen, mix it to the natural gas, put it into reservoirs, and they can do it when we have a lot of excess electricity. This is our 2, 3, 5-year goal. Well, it's also my task as a project manager to manage a project, okay, by definition. So we are working on different scientific and industrial projects. I am involved in one where we put together a platform, a website and a marketplace where people can sell electricity. So you can produce electricity, you can join to this site, you can sell it because you have it, and then we can buy it when we need it. This is also going to be part of the flexibility. I think so far that was my introduction. In case you have questions, I would be very glad to start a discussion in that particular topic. Thank you for your attention so far.
Okay, thank you, Máté. Can we all just, there's a little function here that's like a clap function. Can we just give Máté a round of applause digitally? Thank you so much. And yeah, Q&A session sounds perfect. We have a lot of time for that, definitely. For those of you who want to ask a question, let's just try to keep this informal. So maybe if you could just turn on your camera, raise your hand and just introduce yourself to the audience. Maybe, you know, what's your name, where are you from, and then ask Máté a question. I can maybe start the conversation and just ask. I'm really curious about how you felt going into this job that you currently have with electricity flexibility, because it seems very different from your studies. Is that not true?
Exactly. I was in the academia, research, development, laboratory, and sometimes fieldwork. And then I did a transition to the industry. This was, well, partly planned because unfortunately, I see that the future is rough for geothermal energy. It's at least in this country, in the national plans, solar power is much more preferred compared to geothermal. People can utilize it much easily. And well, I wanted a good position even 10 years from now, even if geothermal might not get funding. I don't have this kind of news. I just felt that solar energy is going to be more popular. So, and that was the place when I had to think, what can I do in the industry? Because I was in the academia, universities. So there I could step back to my project management knowledge, because at the beginning I started in the laboratory, but then I also, by the end, I was assistant to the project manager, and parallel to this European project, I also worked on a different, which I didn't mention, on a different European project, which I helped coordinate. So this was the point where I could connect my knowledge to something useful, more broader. And industry, of course, needs project managers, needs people who are operative, basically. And this is when I could grab a common ground with my current boss. This is also renewable energy because I'm dealing with solar panels and solar energy and basically strategy as well. We advise regulatory measures, we advise laws based on professional opinion. And my experience fits into this, not the laboratory work, but what I am capable of doing. I know I started this job in last November, so I'm here since half a year or so. And of course, it's pandemic, so it's full home office. It's a big change. I have been in home office since earlier times because I wrote my dissertation in home office, so I can work from home. But many of my colleagues who are not my closest colleagues, I have not seen. I have only heard their voices, saw a picture, and that's it. It's a new challenge. It's interesting. Can't wait to join the team and have some team building. Hope I answered your question, and I can just motivate others if you're not prepared to switch on your camera, you can still ask a question.
If also nobody wants to ask a question over voice, you can also put it in the chat as well.
Well, let me just. I have a story about, because it's interesting how you get a job, how you do it. This wasn't the first time for job hunt for me. When I went from Iceland, I came back to Hungary. I started to look for a job. Of course, I decided. You can see now that I decided at a PhD studies, but I was looking for a job back then too. It wasn't easy because I had high standards after Iceland, I wrote a lot of CVs, sent it out to many companies, all kind of engineers, and it either wasn't very successful or the circumstances wasn't somewhat acceptable. But mostly, of course, the remuneration wasn't something I expected. Therefore, I went to something similar because a PhD is in Hungary is not a well-paid job, but at least it has some kind of addition. My career is moving forward, at least. Yeah.
I think we have a question from V. Martin.
Mm-hmm. I don't see it.
Hey V, your mic is quiet for some reason.
I need to get off my headphone. Can you hear me?
Yes.
Okay. I'm going to stay off camera because I'm not quite camera ready, but thank you for your presentation. You were speaking about the pandemic briefly. I just wanted to see if you had some thoughts about would you change your current strategy, knowing what you know now and what you've seen based on the pandemic? Would you consider doing things differently based on what we've gone through with the pandemic regarding your strategies for your project management?
Oh, so you mean professionally or personally?
Well, both, if you want to speak to that.
Okay. Well, I can say that this is a new situation for large and small companies as well. And the company where I'm working at realized that this is cost effective. This is good for their wallet to keep people at their home, have them in home office, and then they don't have to have so big office buildings. Therefore, they are going to implement home office on a larger scale. Now I'm part of a pilot project where even if pandemic ends, I'm going to be in home office. And they, for example, changed their corporate strategy into having less tables in office than employees they have, and have them at least partly in home office. This means I might share a table with someone, but not on the same day, in rotation. Honestly, I think this is not too good. This is not too good because it's not effective. When I'm in a meeting with, it doesn't matter if it's 5 people or 10 people or 30, I don't see their faces. When we need effective discussion, like we have a material and then we have to decide something. This is our common ground. We stand by it. It's very hard to do so online. You don't see their faces, their reactions. It's hard to communicate with them. You know, you have to wait a few seconds after they stop their speech, and then 2 people or 3 people starts to speak together. Okay, you go, no, I go. It's not that effective, but probably employers don't see it immediately. They only see that it's good for their wallet. But in 1.5 years, I think this is the time frame when they realize that it is not that much effective. For example, when I'm speaking on an online platform, Teams, Zoom, whatever, I don't know what they are doing. They might not listening to me. They might drive a car. They might answer different emails. I don't necessarily have their attention. It's not good. It's not effective. Some days, yes, and no one can determine a generic number that this is the optimal. It depends on the person. A few days, I think for me it would be 3 days in home office and 2 personally. And then on those 2 days, I see some faces. I go outside and also have productive meetings on those 2 days. And on the rest, I can do my research, write the reports, write emails, etc. It is personal. Professionally, it does not influence that much because we calculate anyway with electrification and a larger need for electricity. We are improving our electric grid and trying to prepare it for more people, more consumption. You know, many households, or at least here, are not even including gas at all, natural gas, into their house. They heat, cook, do everything completely electrically. Therefore, this home office, few lights, few computers, it doesn't influence that much on an industrial scale. I would say at this time, I think this way.
Okay. Thank you very much. Appreciate you.
Yeah, hi, thank you for your presentation. My name is Alvin. I have a question as well. I'm starting my master's in summer this year at Reykjavik University. And I was wondering if you have any projects ongoing with like distributed systems you control centrally, like heat pumps or something, or electrical heaters for that matter, as you said. And the other question is, since you're talking about a lot of solar, do you have any systems where you actually use this like as a distributed power station where you control it and use it to also produce like reactive power and yeah, to improve the grid quality?
May I ask which country are you from?
Switzerland.
Okay. I only ask this because US is a few years ahead of us, maybe ahead of Europe, but definitely ahead of Hungary. So the European Union published a clean energy package last year, and there appeared first the term flexibility, electric flexibility. This means you can tune up or tune down the producers Tesla chargers, whatever's. This is pretty new. Our legislation, we have law for it and implementation since March. It's 1.5 months. Therefore, no, we do not have a practice. And the easiest for us is to switch off completely the producers when there is trouble. We say we cannot accept more electricity. This is why I said in my presentation, there is way more electricity than we can utilize at this moment. Hungary's electricity production is very rigid, mostly nuclear. There is some gas and some unpredictable renewable source. So rigid and unpredictable, hard to plan with this. It's a longer term strategy, which we are trying to improve and implement to turn consumers. And we do not start on a domestic scale. We start on a bit larger scale. For example, big supermarkets, hypermarkets, switching on some of their equipments when, or giving them a signal that electricity is cheap now. You can heat or cool your devices and your spaces now for a better price. We are in not that much into this technology. In the upcoming 2 years, we are trying to develop a system where we can see the how to say, well, the stance of our grid. We can see green areas where, okay, there is no problem here, but on this line it's red. There is so much problem here. It's high voltages because so much electricity is going on. Here we have to do something. US is a bit ahead, and in Europe, UK, they have a very good and flexible grid. What I see that they did, they have so-called aggregators. They aggregate large amount of municipal houses and like half of the city is one aggregate, other one is other aggregate, and when one has excess energy, can trade with the another half if they need electricity. And of course, there is the question of batteries, but on a longer term, it's also problematic because they are super expensive and don't help us as much in capacity. So to answer to your question, I cannot offer you right now a solution or a project. We are still in the thinking phase. We have national projects to try to put our head together how to progress. I hope that in 1.5 years, we are going to have some flexible solution. Iceland and it's always country and place specific. Iceland is a very good position. Even if they would have electricity from nuclear, which is of course very rigid, they could still use the aluminum smelters to consume the excess energy. So it's very good for them. We don't have aluminum smelters, but it could be a way. If you have excess energy, you just do something energy intensive and then convert it to money in a way. Did I answer more or less?
Yeah, thank you. Do you, maybe to add to that, do you have any plans to, like, with experimental storage technologies as well? I don't know Hungary that well, but do you have a lot of mountains, or do you, how do you, like, what do you plan on also seasonal storage for? Do you just use the gas grid, or do you have like other plans?
Hungary is relatively flat. Maximum height is a bit more than 1,000 meters. We don't have a reservoir there. So hydro, we don't have much hydro. That's again a problem. Scandinavian countries have tons. so they can utilize it. In the Alps, Switzerland, Germany, Austria, other countries might have that opportunity. Unfortunately, we are not good in hydro. Therefore, what I introduced briefly, the power to gas, is so far the brightest solution I have heard. There are many other approaches. For example, smart metering. We deal a lot with smart metering. You know, when you have a household, you have this electricity meter, and right now it's very old. It doesn't give much information. Once a month, they say a number, okay, you pay by that. If this would be smart, sending us data, or at least recording data by every 15 minutes, 10 minutes, 1 minute, whatever, we would have much more information on how to intervene into this electricity consumption and production.
Maybe I can add off of that. Have you considered like battery storage?
We have a pilot project very close to here. It helps when there is a peak, if it's a small peak, but the problem is not only the peaks, because when solar panels start, we have I say solar panels a lot because we have the most problems with them. When they start to produce, it's not only when clouds go away and then they shine for 20 minutes. Okay, batteries can take that, but not more than that. In capacity compared to use and production, they can have maximum 1 hour, and they are very price intensive. It's a futuristic idea to use electric cars and battery of electric cars which are connected to the grid. Problematic, possible, might be possible. We don't have that much battery on the grid. That's the problem, yeah. But some are needed. Some are definitely needed.
Another question about the grid quality, if I may add, what do you primarily use for like frequency control in?
Frequency control, there is a special type of transformator which we use. And that's all I know, but I am not an electrical engineer. Unfortunately, I don't know much about how we actually do it. But as I remember, it's not our company's responsibility because we are just distributing the electricity. We are DSOs. It is more the responsibility of the TSO, the transmission system operator. They get the electricity at the power plant, transfer it to high voltage, and then they transport the electricity there, and they have large equipment with high performance, but I don't know how actually they do it. They do the voltage control. What I know of that we can go 240 watts plus 10%, minus 8%, and then things starts to heat up.
Sorry, I misunderstood. I thought you were like, I somehow confused. I thought you were working for the top level, like grid operator. Sorry, that's, yeah. But thank you.
Yeah, sure. Oh, well, it was a good question, and it's legitimate. We need electrical engineers, and probably we do have electrical engineers dealing with this. I'm probably just have the same diploma which you apply to, and it's not that specific, I'm telling you.
Which one do you have?
Sorry?
Which diploma do you have? Or
I have the Sustainable Energy Engineering from ISC.
okay.
Are you do you apply for the same
Yes, I
program?
applied for that one. Yeah.
Yeah, it's a good one. One thing, if I may add, I hated energy economics. I really tried to get rid of it. Really tried to not do it. It was impossible. I had to do it. I was
It
not
is a useful course to take.
exactly. I was not that good at it, but I could somehow do it. You know, we deal with LCOE, levelized cost of electricity, to compare renewable energy sources. And now, guess what I'm doing as project manager? There's a lot of economics.
Yeah, I mean, maybe one thing I can add, since Máté, you graduated in 2016, the programs have been constantly evolving and improving, and there's different tracks now. And to answer, or at least to go off of the topic of electrical engineering, we actually have a dedicated program to that. I'm not sure if you knew, in electric power engineering.
Nice.
So this is very much dedicated to understanding how electricity is distributed, different components of the electric grid, frequency stability, voltage stability, these kind of things.
Yeah, exactly. In Iceland, I was more into geothermal energy. Probably you can ask me anything. I have tons of publications and conference appearings, and my dissertation is in geothermal energy. It's the past half year when I'm in the electric industry. Of course, I should know everything soon. There is just some priority.
This actually kind of ties back to the original question that I had, which was how was it to transfer, I guess, subject areas? But it sounds like your master's still helped in at least kind of understanding this other side, this electrical engineering, which often is kind of an alien language to those who are not electrical engineers.
Yes, first you get a grip of what you already know. And then you listen to the people talk, you get used to the nomenclature, you read a lot, listen a lot, and then slowly you are getting used to the words. You put a lot of work into their meaning. In the first 1 or 2 months, actually I don't think they expected much, or they usually expect much of the people, because they know that they are new, even if they are coming from the same industry. But the ability to learn is quite a good thing. And then now probably I can have an opinion, a professional opinion in something which I'm not educated in. Because now experience starts to come in. But then again, if I would have to say something about voltage or frequency control, I would say, okay, give me some time. I'm going to get you an electrical engineer. Yes, we can work together in that project, but I need 1 or 2 people who helps me. And being honest is I think is the best thing you can do. Like you don't have to be afraid if you can do something. Of course, people know that I'm not coming from here. You can just say, yes, I can do that. No, I cannot do that. I could do that, but it's not in line with my opinion. Then you discuss and then have some kind of outcome. You have to be direct, and it's not rude, I think, if you honestly tell that you cannot do something. That's correct. That's the correct way.
Yeah, I mean, I think you're definitely right, and I think it's like you said, the ability to learn is kind of part of the reason why we study. I might not know this right now, but I can know it, or if not, I know somebody else who will know it, right? So I think this is actually a good place to end. We've passed kind of the hour mark. I would just want to ask if everybody could give Máté one more round of applause. And also give yourselves a round of applause. Thank you for joining this call, and thank you, Máté, for presenting to our community.
Thank you very much. Keep up the good work of keeping the network alive. I might meet some of the guys here who I can involve, or maybe we will be involved in a future project. It's very good, very good. Keep up the good work.
Awesome.
Thank you again.
Thank you so much. And Máté, if anybody has any questions, can they reach out to you?
Of course.
Okay.
You know my name, and this is enough: Facebook, Instagram, LinkedIn, whatever email. My name is quite specific. It's if you type it into any search, you are going to find me.
Awesome. Well, thank you again, and thank you, everybody.
Thank you. Goodbye.